Hi everyone, welcome back to my vlog. So this time I have my fire pits, including a couple of bugs. So this part, last time I did hemispheres, so this part here is actually a hemisphere. It's just that instead of using a lot of segments for my circumference, I just set it to 4, and so it does a square. That should be a rounded bottom. So, but this is my first bug, so I have a problem with my normal here. This should be visible. Well, it is, but if I go closer, it disappears a bit too quickly. So I don't know if it's a bug about my normal or if it's my system that. Yeah, that's a bug with the normals. See, I should see that little piece. So I'll fix it. The second bug is I discovered that I have a clipping problem with my translucent objects. As you can see, I just saw it. Where is it? Glitch? Okay, you can see it here. That's not good, so I'll have to fix that too. Wow. Okay, well, you know, that's life. Nothing is perfect on the first shot, so... another bug that I had to fix, I did my particle system in an afternoon, so it's pretty primitive and lightweight, but as you can see it does, you know, the essentials. I can do smoke and they're subtle, but I have little things here, so enough to give it a bit of, well, it's actually maybe too subtle. Yeah, so yeah, there was a bug when computing the vertices for my rotating particles, but that was easy to fix. It was a simple emission. Another thing that I added, and you see it nicely here. I mentioned it in an earlier installment of my vlog. The lighting. My first pass at the lighting rasterizer only considered the distance between... So let's say I'm drawing this point of that triangle and there's a light here. So what I did, I computed the distance and I used that to determine the intensity, and this is why it does a kind of a circle. But what happened is that this part used to be as lit as this part, so everything was just overly lit and it just looked like a blob of light pasted on my screen, you know. So by considering the angle between the normals and the light source and modulate, well, I guess multiplying that with the distance intensity, I can have both the distance and the angle to the light as factors that determines the intensity of the light, which makes it much more dynamic. As you can see, you can really tell the 3D-ness of it. So that's it. What else? Oh yeah, this really bugs me. I wish I saw it before doing my video. Okay, there's two things I'd like to consider, but they're not urgent, so I'll put them on the wish list, I guess. Okay, the first thing first. Okay, so I have a dynamic light, roughly here. The problem, well, not the problem, but the reality is that this fire pit is static. You can't move it. The floor is static. You can't move the floor either, and the light never moves in relationship to those three things. So everything is fixed in the world, and I find it a big shame that I spend so much time to calculate a dynamic light when nothing moves. It's always going to be the same intensity, you know. So yeah, I'm gonna consider doing. I might consider doing handmade light maps for my objects that fall into that situation, and this will account for most of the objects that have lights that I'm gonna use. So it might be a good idea to offload a bit of work, you know, to I'm pretty CPU intensive, so any saving is good, you know. The other thing that I ended up doing is that, well, I had a test light, but now I actually added a light manager, which is nice. So I can support up to 8 lights at the same time. And I'm gonna stream them in and out depending on the zones I'm in, so, or the zones that are visible. 8 is a lot. It really is. So I'll see how it goes. I might move it down to 3. And did I mention it? Well, yeah, for example, this situation here well, is also problematic, but that's life. Translucency is always slower, and even though I'm working in main memory, which is faster than VRAM significantly, every time you need transparency, you need to read the old color, compute the new color you want to put, and then write it back at the same place. And memory has a latency, and so you can't do that quickly. You have to wait until everything is read, and then transform it, and then put it back. Because it depends on the old value, it cannot pipeline those memory transactions if you want to optimize them. So you're stuck with a load hit store. Thankfully, in my case, because my rasterizers are in software, there's a lot of computations that could potentially be inserted in between those two steps to at least keep the CPU busy while it waits for the memory to be accessible. Yeah, anyways, I'm getting too technical. Let's just say in debug this is at 28 FPS, so I'm assuming that in release, once the game is filled with stuff, this might be a lagging point, so I'll have to keep that in mind. And there's no real solution. There's actually no real solution that I can think of. Yeah, maybe typically what people do, they just get rid of it. Well, actually, typically, and I'm not kidding, no, game programmers are like, well, too bad. If you stick your head in the smoke, you gotta expect things to lag. It's a rare case. Nobody does it. You know, people tend to just be busy playing, right? So they just accept the life like that. Anyways, oh wow, this is getting a bit long, so I'm gonna stop it here. Thank you for watching, and I really hope you enjoy those. For me, not only I'm having fun, I know I'm not the best at oral skills. It's not my first language, so I need to translate in my head. And also, I'm not used to it, so I'm not good at it yet. So it helps me getting better at that, but also because I'm mostly showcasing what I'm working on, it actually pushes me to work efficiently and more, and I'm really enjoying this. It has... So I hope you're enjoying it too. Alright. Okay, take care. See you next time.